Yesterday we talked about the law of sines. Today we're going to talk about the law of cosines, and this is going on page 99 when we're done. So we're going to start the same way we did yesterday, which is taking this triangle that's not a right triangle and breaking it into two right triangles that we know how to handle. So there's my perpendicular. We're going to call this the height. That's an H. We'll make this point D so we can talk about the triangles. This whole side here, length is C, but I need to break it into these two pieces. So I'm going to call this piece X, and this piece is going to be C minus X, because when I add those together, I get C back. All right, so this explanation of how it gets derived, I feel like you seeing this math and understanding the math behind it is important, but I know sometimes I lose some of you in stuff like this because all you're thinking in the back of your head is, I will never be able to recreate this, or I would never think to do this. Well, a lot of times on the proofs, I wouldn't expect you to know to find these specific pieces, but hopefully you could at least follow the math that I'm doing. You're not going to have to recreate it, but I want you to see that it's not just something that somebody said, hey, let's use this formula that I just made up, that there's a mathematical basis behind it. So we're going to start by looking at triangle ADC, this triangle right here. So triangle ADC. And I'm going to set it up with Pythagorean theorem, okay, and I'm going to use B, well, obviously, I have to use B as the hypotenuse, but I'm going to put it first. Usually we put the hypotenuse last, but I'm going to put it first. So I'm going to have B squared equals, it's going to be C minus X squared plus H squared. And then I'm going to square that out, or FOIL that out, so B squared is equal to C squared minus 2cx plus x squared. So that's the trinomial I get from this, and then plus h squared. Okay? So then I'm going to pause there for a minute, and then I'm going to go look at triangle CBD, the other little triangle, okay? The other right triangle that I know what to do with it. I'm going to set up Pythagorean theorem with that too. So triangle CDB, when I do Pythagorean theorem there, that's going to give me, and I'm going to put the hypotenuse first again, a squared equals x squared plus h squared. Okay, and then I'm going to pause right there. Then I'm also going to set up something for angle B, okay? Because with the law of cosines, you're going to use one of the angles, or be looking for one of the angles, basically, and the angle that we're looking for is related to the side opposite of it. So our end goal over there is B. So I'm going to use this angle B right here, and I'm going to set up the cosine of angle B in this little triangle right here. Okay, so the cosine of angle B from the right triangle over here that I can find, it is the adjacent, which is X, over the hypotenuse, which is A. And then I'm going to solve for X, so I multiply both sides by A. So X equals A times the cosine of B. So now I'm going to take these pieces and I'm going to do some substitution, because in the end I really need to get X and H both out of this equation, because if I have H, that means I'm using these right triangles, but that's not going to be there, so I'm not going to have a right triangle. And then since I'm not going to have that, I'm also not going to have the hypotenuse split up. So I basically want to get X and H out of this. So here's some substitution that I can do. A squared equals X plus H squared. You see this X plus H right here? That's going to be substituted to become A squared. And then we have X equals A times the cosine of B. So this X, so this will be plus A squared instead of X squared plus H squared. This X is going to get replaced with A times the cosine of B. So this is going to be minus 2 times C, and instead of X, it's going to be A times the cosine of B. Kind of ran out of room, but I'm going to rewrite it anyway. And then before that was the C squared, and that's backing it up there. So I replaced this right here that says A cosine of B. Replace the X, and then the X plus H squared is replaced by A squared. So I would need to rewrite it anyway, because I'm going to rearrange it. We usually write our letters and stuff alphabetically, so I'm going to leave it as B squared, and that's equal to, so I have this C squared, this crazy big term, and then A squared. So again, we're going to go alphabetically. This is going to be a squared plus c squared, because both of these are positive. And then minus this thing right here, but I'm going to switch these two around too because I can multiply in any order, and we put a first. So minus 2ac times the cosine of angle B. This right here is what we can use to find side length B. Now, here's the good news. We can use this to find any side length, and the letters, really don't matter. Here's what you need to keep in mind when you go to solve this, because we're going to have 3 different versions we're going to write down right here. Notice that I'm looking for B, and B squared is over here by itself. The side length of B is not over here again, right? And the angle B is the one you take the cosine of. So whatever the side length is that's by itself over here relates to the angle, or is across from the angle that you're going to use to find the cosine of. What's inside of here, this is the Pythagorean theorem, basically. So if B squared's here, I have to have the other 2 squared and added together right here. Then minus 2 times, and look, those 2 letters are the same as these 2 letters. So it's really not that big of a deal to remember. So we're going to have 3 different versions that we're going to write in right here. This one right here is going to go in the second line. So let's just rewrite what we have. B squared equals a squared plus c squared minus 2ac times the cosine of angle B. So let's say I want to find angle A, or not angle A, side A. And I don't have, I don't have my x, and I don't have any of that information. Then this would be a squared. Since this is a squared, these 2 that come next would have to be b squared plus c squared. And then since this is b and c, it's going to be minus 2 times b times c times the cosine of the angle that's across from side A, which would be angle A. So take a second, write down the third one that would start with c squared. Follow that pattern, then c squared should be a squared plus b squared minus 2ab times the cosine of c. So really, if you understand one of them, you understand all of them. It's not like there's really 3 formulas. And when it comes right down to it, you need to understand the global concept of it a little bit better, being that the side that you're looking for, that side squared, is equal to the other 2 sides squared and added together, minus 2 times the other 2 sides multiplied together times the cosine of the angle that's across from the side you're looking for. So you have the letters be whatever. The number 1 doesn't even have any letters on it. Okay? And also, I've messed this up again. It says nearest tenth. They should all be the nearest thousandth. So let's think about that using these. It says find each side length. So we're looking for x. So that means that x squared is equal to the other 2 sides squared and added together. So 16 squared plus 28 squared minus 2 times these 2 sides multiplied together, 16 times 28 times the cosine of the angle that's across from that side, which is 127. Okay? That's it in a nutshell. Now, if you're using the calculators we have in class, then you could go ahead and, type it in all in at once. If you are using a different calculator, that maybe that's just a little much to type it all in at once, then you can maybe do it in 2 pieces, meaning you wouldn't necessarily have to do this step, but we could do x squared equals, and then if I just do 16 squared plus 28 squared, that would give me 1040, and then minus, and I'll do 2 times 16 times 28 minus 896 times the cosine of 127. That's a little less to type in all at once. You definitely, again, don't have to do that step, but you can, and then, just get it down a little bit cleaner. But you can type this in all at once, and the nice thing about these calculators that we're using in class is that you can actually see everything that you typed in real good. So once you type all that in here, you're going to get x squared. Now in your calculator, the number that you get, which is like 1579, ... right? That is not your final answer. That is x squared. You don't want x squared. So that number should still be looking at you in the calculator. I didn't write down the decimals because we're not typing them back in, but you can hit the square root button and then the answer key down next to equals, and it'll take the square root of the stored number that you have there, and you get in the end then that x is equal to 39.739 inches. We have units here. Use your units. Okay, let's look at number 3. It says in triangle ABC, the measure, okay, so it gives me all this information. And I want to find the length of AB. So I don't have a picture. I need to draw it. So I'm going to draw it over here just so it doesn't take up any of our workroom. I'm not sure if we're going to need it or not. But so draw my triangle. Say that this is A, B, and C. All right, so angle C is 88 degrees. The length of AC is 22 feet. And the length of BC is 11.5 feet. And then I need to find the length of AB, which since it's across from angle C, I'm going to call it lowercase c. So remember, you have to make the decision eventually whether you're going to use this law of sines or law of cosines. So you have to be able to identify what type of triangle situation you have here. This is 2 sides and the included angle, so it's side angle side. And it says up there, we're going to use the 2 sides and the included angle, or 3 sides. Way up here at the top, I don't even know if I remember if I said anything about it, but we're using side angle side and side side side, which yesterday we used the other ones. So let's go back down here. All right, so now that I have this, I'm looking for side C, right? So I'm going to write this out. I know that C squared is equal to the other 2 sides squared, which would be basically A squared plus B squared, but we could type those, or just go ahead and substitute those in. 22 squared plus 11.5 squared minus 2 times 22 times 11.5 times the cosine of 88, which is the cosine of C, the angle that goes with it. So have all that. You can type it all in. Go ahead and try and type it in maybe all at once if you didn't do that last time. Remember to use the squared button as you go. Makes it a whole lot easier. So once I've got mine typed in, that's what you can see right there. And so I can arrow to the left so I can see the rest of it and make sure I typed it all in correctly. So I'm going to hit equals. Gives me that number, but remember, that number is not my answer. That is C squared. So I hit my square root button. Then I use the answer key down here by the equals. So it tells me it's going to take the square root of the answer. I hit enter. Bam, there's my number. So C, which if I say C is equal to 24.466, that's not good enough for my answer. Even when I put feet on there, still not good enough. Because nobody asked me for C. You were asked to find the length of AB, which is what we labeled as C, but we labeled it that way. So I need to say that that's equal to the length of AB. And it's fine to write it, the label at the end. Just make sure you have your units on there as well. Okay? So we can also use, so we have side angle side. You're going to be using this to find a missing side. If you have all 3 sides and you have side, 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 you're going to be able to use it to find a missing angle. Okay, so again, it says round to the nearest tenth, but we are ignoring that. So we start kind of the same way. You can see the law of cosines rewritten in a different form where we basically solve for the cosine value. But honestly, I think it's better to have one formula that you remember. You do it every time, and then you just know how to manipulate it. Having 1,000 different formulas is not helpful to anybody. So we're going to find x. So here's the deal, though. I need this angle measure. So remember, when you take the cosine in the law of cosines, the angle that you're taking the cosine of is directly across from the side that's squared outside by itself. So when I go to substitute stuff in here, I'm going to have, this is my x that I'm looking for. So 10 squared is the one that's on the outside. 10 squared is equal to the other 2 sides squared and added together. minus 2 times those same two sides multiplied together times the cosine of that angle, which is x. So this time I'm not typing it all in the calculator all at once. Here I really think it's easier if you go ahead and kind of make it to that second step that we did up there. So I'm going to square this. This is 100 equals, and then you can do 13 squared plus 11 squared and get 290 here, minus 2 times 13 times 11, 286 times the cosine of x. Okay, so can I go ahead and subtract 290 and 286? What do you think? Heck no, because this is attached to it. But I need to get x by itself, so I need to move this 290 over here. So if I subtract that from both sides, that's going to give me negative 190 equals negative 286 times the cosine of x. Still need to get the cosine of x by itself, so I'm going to divide both sides by a negative 286. So I have negative 190 divided by negative 286, and that's equal to the cosine of x. Now, that's going to reduce. I know for sure it is because they're both even. I don't care what it is. Don't bother reducing it. It is totally not worth your time. The only thing I would suggest right here, though, is to go ahead and, negative divided by negative is a positive. So when I want the cosine of x, to get cosine away from x, that is the cosine inverse. So the cosine, oops, one second, sorry. So x equals the cosine inverse, I'm going to go ahead and drop the negatives here, of 190 over 286. Whether I reduce it or not, I'm going to get the same answer in the end. So I take this cosine inverse of 190, sorry, typing in the wrong numbers, cosine inverse of 190 divided by 286. So I get that x equals 48.369. So do I put a degree sign on here? Well, it says find the angle measure, so our angles are measured in degrees. However, if I put a degree sign on this, and then I substitute it in here, I'd have the degrees to the degree power be like degrees squared, which makes no sense. So technically, x is just 48.369 because the units are already in here. That's my answer. Okay. On the back. Let's look at number 6. In triangle RST, the length of RS. Okay, so again, that's naming me a triangle that I don't have, so I'm going to draw it. RST. The length of RS is 9 centimeters. The length of ST is 14 centimeters. The length of RT is 6 centimeters. And I want to find the measure of angle R, this angle right here. So we'll call that theta. Okay, so it's side, 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 so I have to use the law of cosines. Law of sines wouldn't make any sense because I don't have any angles, so I don't have enough for that, obviously. This is my theta. This is the side that's across from it. It's the one that gets squared out here. So 14 squared is equal to the other two sides squared and added together, plus 2 times those same two sides multiplied together times the cosine of the theta that we don't know. So I'm going to clean this up just a little bit, and we should know that 14 squared is 196. That's equal to, and then 6 squared plus 9 squared is 117, plus 108, oh not plus, shoot, that's minus. Sorry about that. This is always, you always add the 2 squared and then you minus that. Mess that up. Okay, so that should be 117 minus 108 times the cosine of theta. So now 196 minus 117, which is 79, and that's equal to negative 108 times the cosine of theta. So that's negative Might seem weird, right? But let's see what happens. So I'm going to divide, and I know then that cosine of theta is equal to 79 divided by a negative 108. There's only one negative, so I don't get to cancel those out. So theta is equal to the cosine inverse of 79 over a negative 108. So once I type that in, cosine inverse of 79 divided by negative 108. Make sure you don't minus 108. The negative sign is above recall. And hit enter. And I get that theta equals 137.011. And this will be degrees. But remember, they asked me for the measure of angle R, so that's equal to the measure of angle R. And there you go. You could type this in all at once, meaning that, like, I'm going to write right here, because we're not going to do this problem right now, but don't write right here because we are going to do this one on Tuesday. But when I get to right here, I mean, yes, you could do it all together. I would be careful about how you subtract that stuff. I would say at least get to this so you don't do anything weird. But in your calculator, you could type 196 minus 117 and make sure it's all over negative 108. And you could do that and get a number if you wanted. Or even then you could take the cosine inverse of that, because you can do it in more than one step. But my fear here is that you wouldn't actually subtract both of those, but just another option there. Right, and then so like I said, we are not going to do the application problems today because when we talk about bearing and stuff, I need to be able to explain that to you a little bit better. That I don't feel like I can do that from a video. So just on your assignment, 1 through 8 is all the ones that are not the word problems. Those are going to be due Tuesday. Yes, Tuesday, because you have time in class now to do it and you can finish it by Tuesday. Turn that in on Tuesday. I'll give you another piece of paper that has the word problems on it, but I don't want you doing those until we can talk about how to draw things correctly. So now that you are done with this, go ahead and glue or tape this in and ask the substitute for your assignment.